Every space film should begin with a launch.
5, 4, 3, 2, 1, 0. We have ignition. We have a liftoff.
Because that's how space began. On the 16th of March, 1976, NASA celebrated the 50th anniversary of the first successful liquid-fueled rocket flight by Dr. Robert Goddard. It was a joyful, if somewhat soggy, occasion.
We at Goddard will penetrate even further into the distances and mysteries of the universe and of Earth, but as usual, without most of us ever leaving our offices and laboratories.
Goddard Space Flight Center is a kaleidoscope of extremes, ranging all the way from a university campus to an industrial complex. It's a partnership of physicists, astronomers, mathematicians, engineers, managers, and experts in almost any high technology or craft you can think of, teamed together for the mastery of space. Around the clock, whatever the weather, these buildings fill with the quiet, far-thinking men and women who are producing the ideas, systems, and hardware which is gradually changing our world and improving the overall quality of life on Earth. The Goddard mission begins with very human, current, pressing needs of two types. The first is the need for fundamental knowledge, the knowledge that comes from basic scientific inquiry.
We in the space sciences look from planet Earth to our solar system to the far reaches of the universe. Instruments on spacecraft are the extension of our senses, ranging from radio waves to gamma rays. Our aim is to understand the forces of nature that shape man's environment.
In this enormous task, each investigator takes a small part of the responsibility within his scientific discipline. The second basic need which Goddard serves is the need for just plain everyday help, what we call applications. When will it be the best to plant? Is there a threat of a flood? What is the sea state east of Borneo? Is an earthquake coming? Can I get a call through to Tokyo now? Will the Olympics be telecast? Have they found the missing plane? At the edge of Goddard's main site, there is a fully operational tracking station which is part of the worldwide network and also serves for training. Tracking sites are positioned in Australia, Europe, South America, Hawaii, and Alaska to obtain complete coverage, especially of low-orbit satellites like Landsat and those used in manned missions. Goddard also uses specially instrumented aircraft and ships to support split-second decisions over remote areas during the critical Earth orbit and re-entry phases of manned flight. But the most fascinating new development is the use of lasers in tracking. Skylab astronauts describe them as the brightest spots on Earth, and their accuracy is so great that satellites can detect a landmass shift of only inches spanning New York and California. Here in Goddard's Network Operations Control Center, the commands and predictions flow out and the data streams in. From this room, they manage the daily workload of up to 50 satellites, working in 6 nearly independent disciplines, 3 in science and 3 in applications. On that day in 1969, when we first landed on the moon, 132 science and application satellites had already been put to work. Today, the number exceeds 200.
If you're surprised at the number of spacecraft which have been put to work by Goddard alone, you may be even more impressed if you think of what it takes to design, build, test, and fly each single one. Every component, power supplies, attitude controls, sensors, and electronics, all must survive the test director's cleverest tortures. From the punishing vibration tests simulating the violence of heavy acceleration up through the Earth's ocean of air, to the massive anechoic chambers and vacuum chambers simulating the environment of outer space. The project team, the scientists, engineers and managers must see that everything comes together on the launch pad, on time and with total reliability one day, several years in the future. The program may also have to survive frequent design upgrading as the multiple states of the art advance. Piece by piece, it all comes together in the surgical cleanliness of integration and final assembly, where again, they must prove that they all work separately and all work together well. The moment of launch is thrilling and important, but the great moment, for those who have worked so long and so well, comes after a successful orbit, when the first commands are given, when the first cataract of data starts toward Earth, when it is successfully reduced, analyzed, and passed to the experimenters. Then, only then, all prayers are answered.
The more than 100 tons of instruments, sensors, cameras, relays, and telescopes which have been sent spinning so effortlessly about our Earth have touched us all. You can measure it. Long-distance calls are cheaper. The savings from increased accuracy and range in weather prediction is computed in billions. The cash benefits daily to shipping, farming, forestry, prospecting, control of pollution are readily acknowledged by those in the field. From basic science, even more dramatic applications will flow. Discoveries which will help us protect our near-space environment, increase our understanding of the mechanics of earthquakes, teach us how to relate the activities on our sun to events here on Earth. The next generation of effort will be based on multi-mission spacecraft carried on board the space shuttle of the 80s, making space research ever more accessible, more routine, and more cost-effective. It is everything that Dr. Goddard predicted, and more. How happy he would have been to join the 6 others riding that rocket into space with its vital payload of instruments and experiments.
I have here a copy of a letter written in 1932 by Dr. Goddard to the famous historian and futurist H.G. Wells. Let me read just one paragraph for you. To me, this one paragraph says it all. How many years I shall be able to work on the problem, I do not know. I hope as long as I live. There can be no thought of finishing, for aiming at the stars, both literally and figuratively, is a problem to occupy generations, so that no matter how much progress one makes, there's always the thrill of just beginning.